Hi everybody, welcome back to this course on Internet Technologies. I'm Vardan and today we'll be studying about SSH and IPsec. SSH or Secure Shell is a cryptographic network protocol that enables secure remote access to systems over unsecured networks. It was created to replace older protocols like Telnet and remote login, which transmitted data including passwords in plain text. With SSH, users can remotely log in, execute commands, transfer files, and even forward ports. One of the SSH standout features is that it encrypts all data in transit, making it immune to packet sniffers and man in the middle attacks. Let's also briefly explain tunneling and port forwarding, which are often used interchangeably in SSH. Tunneling refers to creating a secure channel to transmit arbitrary data through an SSH connection. Port forwarding is a form of tunneling where traffic from a local port is forwarded to a remote system via SSH. For example, developers might forward a database port on a remote server to their local machine, allowing them to access it securely without exposing it to the internet. Now, SSH supports two main authentication methods. First is the password based method, which is the simplest and most widely understood method. The user provides a username and password, and SSH ensures that these credentials are encrypted before being transmitted to the remote server. While it's easy to set up and works out of the box, this method has security limitations. Passwords could be weak, they could be reused, or they could be stolen. So while SSH does encrypt the login process, this method is still considered less secure, especially on public facing servers. The other method is public key authentication, which is more secure and scalable than passwords. Here's how it works. First, the server stores a copy of your public key. When you attempt to connect, the server generates a random challenge. It encrypts this with your public key and sends it back to you. A challenge is just a random block of data. You then decrypt the challenge using your private key. You hash the result and send the hash back. If the hash matches server's expected value, the authentication succeeds. This process ensures that even if someone intercepts the transmission, they can't impersonate you without having your private key, which should be securely stored and optionally protected by another passphrase or password. In version 1 of the SSH, two types of RAC keys were used. A long-term key, which was typically 1024 bits, was used to identify the server. This key rarely changed and it helped clients recognize they were connecting to the correct host. A short-term key, about 768 bits, was generally granted for each session or refreshed periodically, like it could be hourly for or for every session. This key was used for actual data encryption within the session, offering a degree of forward secrecy. So even if a forward key or the short term key was leaked, it would be of no use in the future. However, SSH version 1 had several vulnerabilities and is now deprecated. Modern SSH implementations use version 2, which standardizes stronger keys, typically the 2048-bit RSA, or even better algorithms and improved protocol structure. Now, you could be confused between SSH and TLS as they are both cryptographic protocols designed for secure communication, but they serve different purposes and they operate at different layers of the network stack. SSH operates at the application layer and is used primarily for remote administration, secure shell access, and file transfers. It lets administrators control servers and devices over encrypted sessions. On the other hand, TLS operates at the transport layer. It provides a secure channel for protocols like HTTP, SMTP, and IMAP, forming the backbone of secure web communication through HTTPS. So while TLS secures web traffic, SSH secures interactive and administrative access to systems. Now we come to IPsec or Internet Protocol Security. It's a suite of protocols designed to secure IP communication by authenticating and encrypting each IP packet. Unlike SSH and TLS, which work at higher layers, IPsec works at the network layer, directly securing the data in IP packets. It's widely used in VPNs, that is, virtual private networks, for scenarios like host to host communication, firewall to firewall communication, or router to router communication, or host to gateway. IPsec has two major parts. First is the proper IPsec protocol, which defines how packets are encrypted and authenticated. Then is the key management protocol, which uses Internet Key Exchange or IKE to securely negotiate keys. There are two versions of IKE. They are IKE v1 and IKE v2. IPsec also has two modes of operation. One is the tunnel mode, and in tunnel mode, IPsec encrypts the entire original IP packet, including both the header and the payload. The encrypted packet is then encapsulated within a new IP packet. This provides strong protection because it hides the original source and destination addresses, preventing traffic analysis and offering privacy at a deeper level. Tunneling mode is typically used in virtual private networks, especially in site to site connections from two secure gateways. It ensures that the internal network structures remain hidden from external observers. Transport mode is the second mode of operation under IPsec. Here, only the payload of the IP packet, that is the TCP or UDP headers and the application data, is encrypted. The IP header remains unchanged and visible. This mode is used for host to host communication, such as between two individual devices. It introduces less overhead because it doesn't wrap packets in new IP header. However, since the original source and destination IP addresses still remain visible, this mode is less private and doesn't prevent traffic analysis. IPsec offers a robust set of security services. Confidentiality is achieved through encryption, ensuring that intercepted packets can't be read. Authentication confirms that the data is actually from the intended sender. Integrity ensures that the packet hasn't been altered in transit. Replay protection guards against attacks where the old packets are resent to fool the recipient. However, IPsec has notable drawback. It doesn't work well with the NAT, that is network address translation. That's because IPsec protects the IP header, which NAT needs to modify. Any change by the NAT would invalidate the authentication check, breaking the communication. There are workarounds like NAT traversal, that is NAT T, but it's still a limitation in many environments. And that's the end of this video, and in the next lesson we'll be learning about HTTPS and ACE HTTP. So thank you for joining in, and I'll see you next time.